Welcome back to Chapter 6, Bone in Anatomy and Physiology. This is video number 10. So now that we have talked about how bone develops in utero, now we're going to look at the time frame from birth until the end of the teenage years. So we're looking at how bone grows. So we're not forming the bone itself, what we are adding to the bone. And we're going to see that we have two different ways that we can do this. We can either grow the bone in length or we could grow the bone in thickness. So most of this bone growth occurs by growing wider and longer. And most of this takes place in childhood and teenage years, so adolescence. And a lot of this is under the influence of hormones, especially during puberty. So we're going to have hormones influencing the secretion of bone formation. Most of that is due to a hormone called growth hormone that is secreted by the pituitary gland. In any instances where bone growth does not stop after puberty, most of the time that is due to some kind of tumor on the pituitary. And in fact, the tallest known person who was over 8 feet tall had a pituitary disorder, and his bones just kept on growing because of the influence of these hormones. So let's look first at how bone grows in length. So we're going to use this diagram. So this occurs in long bones at the epiphyseal plates, so our growth plates. So this is a diagram. If we took that very small area of hyaline cartilage and blew it up, this is a diagram that represents this. So up here is the epiphysis end of the growth plate, and down here is the metaphysis, and here would be the diaphysis. So this is that middle section between the epiphysis and the diaphysis that we call the metaphysis and the epiphyseal plate. So we're going to have names for the four zones, but they are continuous with one another, and we're going to describe what is happening in each one. So this up here would be bone tissue. This would be bone ECM. And you'll notice that we have an artery here that actually is going to go down into this bone a little bit and this area of cartilage. So it's going to supply this. So this area here does not have any blood vessels, so this part is all relying on diffusion. So the top part of it is going to be penetrated by these arteries. So this is called the zone of resting cartilage. So in here we have small scattered chondrocytes within hyaline ECM. So we have hyaline cartilage ECM. So really we don't have anything going on here. This is just a layer of cartilage, and it kind of serves as a link between the bone tissue and the rest of it. So it anchors this. A lot of times this is the area that is going to shift if you do break your bone at the growth plate. So we can have a lot of issues. So this one and the one down below are typically where they are. And if they don't realign the bone correctly, your bones can grow a little bit awkwardly and cause a lot of problems later in life. So as we move down or distally away from the bone, we end up coming to the zone of proliferating cartilage. And this zone, you can see the chondrocytes are kind of stacked up. So we have stacked chondrocytes dividing. So we have them actively dividing by mitosis and producing lots of ECM. So that's why it's proliferating. To proliferate means to be fruitful and multiply. So these are doing that. Down below, we can see that this is called the zone of hypertrophic cartilage. So these are enlarged chondrocytes. We are having lots of ECM made. So this area hypertrophic means that they're getting really big. So they're bigger than they were before, and they're growing bigger as we go down. And as they grow bigger, they're pumping out more ECM. So these chondrocytes, even though we don't call them chondroblasts in this, they are actively making some ECM. So something has triggered them to make this. Normally they would just sit there and make a little bit of ECM, but they are influenced by hormones to pump out more. And then we get down here to the zone of calcified cartilage. So in this zone, we are beginning ossification, which is going to be here down at the metaphysis. So this is the bridge between cartilage and bone forming through the process of ossification. So here, you can see that the chondrocytes don't look so good. They begin to die. And calcification is triggered. So as you can see, we are building up layers of tissue. So this is actually going up in this direction as more and more layers are formed. So this is traveling up, which means that this bone is growing and the diaphysis is elongating. And since we have epiphyseal plates at both epiphyses, the diaphysis is going to stretch out. And hence, our legs get longer, our arms get longer. What happens is this normally stops. So in order for that to happen, the plates must close. And this happens around 18 years old in females and about 21 years old in males. So hormones, again, influence osteoblasts to produce ECM, which is our growth phase. If the hormones decrease, we decrease osteoblast activity, and growth stops eventually. So we would end up not having as much influence on these different zones, and the ossification continues until it stops. So the hyaline cartilage forms bone, and we end up with the epiphyseal line, which is a remnant of the growth plate. So you can judge a bone on how old the individual is if there is still cartilage present, or in an older individual, it would just look like a line, and it would be bone tissue the whole way through. So as a person is growing, this epiphyseal plate is cartilage.